And the good news is that today we're going to learn the last technique for factoring. We're going to add a couple more things to our list of factoring rules. And then tomorrow we're going to practice those. The next day, let's see, tomorrow we've got a quiz, right? Is that right? Tomorrow we got a quiz. Let's see, what day is that? Let's pull up that calendar. Make sure we're all clear here. Yep, quiz right here. We'll do some general factoring on this day. We'll do applications here. We'll review, and then got the next exam a week from today. Remember, that project is due tomorrow. I took a look at a couple of those yesterday. Looked pretty good. Okay, so the word sum refers to what mathematical operation? Okay, so that's addition. We talked about the word difference. It corresponds to subtraction. And if we want to factor this thing right here, let's see, this starts with a perfect square and it ends with a perfect square. But if you take the two of those, that's an x and that's a 1. Building on what we worked on yesterday, that would be a 1x. If you double it, that's the wrong middle term right there. If you tried to do this using the easy type of factoring and said, let's see, I need an x here and an x here, and then I need two numbers that multiply to be 1 and combine to be 1. Are there any numbers that do that? Nope. So what would we say on this one?
Prime.
Okay, we'd say this one is prime. Okay? And then yesterday we listed out a bunch of perfect squares. We listed 1 through 15, and I said you ought to be familiar with those. 1 through 12 ought to be a piece of cake. That should be something that you have already memorized. But then maybe add 13, 14, and 15. If you can know 16, 17, 18, and 19, that would be great, but you also ought to know the perfect square of 20, which is 400. Okay? Well, now we're talking about perfect cubes. So we need to cube each one of these numbers. So if I cube 1, I get 1. Cube 2, I get 8. Cube 3, I get 27. 64. 125. And then they get a little more difficult. So that'd be 36 times 6. Multiply that all out, you get 216. Okay, now 7 cubed comes up occasionally, 8 cubed sometimes, 9. But 10 cubed comes up a lot. 10 cubed is 1,000, a 1 followed by 3 zeros. Okay, those numbers right there, if you see those, I mean, you should know for a fact they're perfect squares. You ought to know immediately. Okay, now if you see 343, at least I think I'm remembering that, right? 343, I think it's 7 cubed, okay? All right, so some of those you just need to be able to recognize. Others you should know by heart. These definitely you ought to know by heart, okay? All right, now, some of those other techniques that we've learned. So if you learned how to do trinomial grouping, that's great. If you don't like that and you always do guess and check, that's okay. If you learned a different way to think about difference of squares, that's fine. But there are some factoring formulas that you cannot get away without just flat knowing. So that's some of the ones that we're going to talk about today. We're going to talk about difference of cubes and sum of cubes. Now, I've got a difference of cubes right here. It's got 2 terms. So we already learned how to do difference of squares. That had 2 terms. And now we're going to do difference of cubes and sum of cubes. Okay, so each one of those has just 2 terms. Okay, and here's how we check to see. It's a similar checklist to the one that we went through before. The first term has to be a perfect cube. So is that a perfect cube? Yes. If so, of what? And in this case, it's x. Okay, the second term has to be a perfect cube. Is 8 a perfect cube?
Yes.
Yes, of what? 2. Okay, and then it's either got to be a sum or a difference. Now we're going to work on all difference of cubes right now. So if this is a difference, if it's a minus, then what we have is a difference of cubes. Now this formula, this is the answer. If you have a perfect cube minus a perfect cube of A minus a perfect cube of B, perfect cube of the first one minus a perfect cube of the second one, then it's going to be the first one minus the second one, the first one squared. This factor is going to end with the last one squared, and then the middle one is going to be just the 2 of them multiplied together with a plus. So this is a difference of cubes. It fits that pattern right here. So this is going to be x minus 2. Then I start a set of parentheses. I'm going to start with a perfect square of x. I'm going to end with a perfect square of 2, so that's going to be a 4. I multiply these together, and I put a plus in front of it. So it's just x squared plus 2x plus 4. Okay? I mean, if you don't know the formula, it's pretty much impossible to guess and check your way through this. I'm not aware of a way to guess and check, okay, on a difference of cubes. You either know the formula or you don't. And I can absolutely guarantee you're going to find one of these on the test that you take next week. You're probably going to find one on the quiz. And it's very likely that you'd see something like this on the final exam. So these are things that you want to get straight. You want to know how they work. Okay, are there any questions there? Okay, I need your attention. Stop working ahead. I know some of you get this, but I want you to watch here. Some people look at this and they say, well, wait a minute. This is an easy trinomial. I ought to be able to break this down. So let's try and break that down. I'm looking for two numbers that multiply to be x. That's x and x, or sorry, x squared. That would be x and x. I'm looking for two numbers here that multiply to be 4 and combine to be 2. Multiply to be positive 4, combine to be positive 2. Well, let's make a list. 1 and 4 multiply to be 4. Can you make a 2 out of a 1 and a 4? Nope. 2 and 2 multiply to be 4. But can you make a 2 out of a 2 and a 2? No. You're either a 4 or a 0. There's no in between. Okay? So this does not factor. This piece right here is prime. The good news about the difference of cubes and the difference of squares, sum of cubes formula, is that this part right here is prime. It doesn't go any further. Okay? We're stuck right there. Any questions? Okay, again, if you'd think of it this way, perfect cube minus a perfect cube. So it's going to be the first one minus the last one, first one squared, last one squared, and then just the two of them multiplied together. Okay, and I'll tell you how to keep these straight in just a second. Let's take a look at this example right here. This has two terms. It's definitely not a difference of squares. It is a difference, but these are not perfect squares. Is this a perfect cube of what? 3b. Is this a perfect cube of what? Z. Now the cool part about this is if you know the formulas and you know the patterns, this for a lot of people looks really confusing because there's more than one variable. We don't care. It's going to be the first one minus the second one. Then it's going to be the first one squared, 3b squared, so that's going to be 9b squared. The last one squared, so that's going to be z squared. And then I literally just take the two of these together, multiply them. So that's going to be 3bz. And what sign do I put here? I put a plus. Okay? And that right there is the answer. Okay? If you know the formula, it's very simple. It's easier than trinomial grouping. It's easier than any of the other techniques if you know the formula. Okay? All right, so let's take a look at the next one. This is the other formula, and the last one that we're going to learn. This is a sum of cubes. The checklist is exactly the same. The only difference is it starts with a perfect cube, ends with a perfect cube, and it's a sum of those two. So we're adding the two of those together. So on this problem right here, that's a perfect cube of x. That's a perfect cube of 3. So it's the first one plus the second one. So this is going to be x plus 3. Then it's going to be the first one squared, so that's going to be x squared. It's going to be the last one squared, so that's going to be a 9. I take the two of them together and I multiply them, so that's going to be a 3x. And what sign do I put in there? I put a minus. And there's my answer on that one. Okay, now, look at this ugly mess. Two terms. They don't have anything in common, so I can't take anything out. So I ask myself, is this a perfect cube? It is, of 2 and x and y. Is this a perfect cube?
Yes.
Of 5. So I write down the first one plus the second one. Then I write down the first one squared. So the square 2 you get 4, square x you get x squared, square y you get y squared. Ends with a perfect square of the second one, so this is going to be a 25. And then this middle term is literally the two of those multiplied together, so that's going to be a 10xy. And what sign do I put there? I put a minus. Now, those formulas are very similar. They look a lot alike, so I'd like to tell you how to keep them straight. Everybody ready? Okay, now these are the three formulas that we use to factor two terms. If you have two terms, everybody listening? If you've got two terms and you've already taken out the greatest common factor, this is the only way these will factor. It's either a difference of squares, a difference of cubes, or a sum of cubes. Nothing else. If one of these does not work, it's prime. Okay? All right. So let's take a look at this right here. We've got a squared minus b squared. That's a difference of perfect squares. It factored to a minus b and a plus b. First one minus the second one, first one plus the second one. This is a difference of cubes. A cubed minus b cubed. It factors to first one minus the second one, first one squared, last one squared, and then just the two of them multiplied together. If it's a sum of cubes, now remember there's no sum of squares formula, okay? First one cubed plus second one cubed. It's going to be the first one plus the second one, first one squared, end with the last one squared, multiply the two of them together, and just put a minus there. A couple things I want you to notice. Each formula has only one negative. So there's only one negative here, only one negative here, and only one negative here. It's always in the middle of the factor. So it's in the middle of this one, and the middle of this one. Okay? And the first factor always has the same sign or the same operation as the original polynomial. So if this was a difference and a minus, that's a minus here. That's a minus here, that's a minus here. If this is a plus, that's a plus. So where does the negative go? It's got to go in the middle of the second one. Okay? Tyler.
Question with sum of squares.
Yep.
That would be prime because you can't.
Right. Sum of squares would be prime. Yep. Okay. Any questions? Okay. If you have two terms, this is the only way you're going to be able to factor. Okay? Okay, you're going to run into a bunch of problems like that. So all we need to do is determine what it is. Okay, watch please. Okay, the first thing we notice is this is a sum. We've already thought in our heads, can I take out a greatest common factor? There's not one. It's a sum. I know immediately it's got to be this one. If this one doesn't work, I'm done. I'll just say it's prime. So perfect cube of m, perfect cube of 5. So I write down an m and a 5. What sign goes in between here? It's going to be a plus, same as that one. Then I just need to remember what to write down here. Perfect square of the first one, perfect square of the last one. Multiply the two of them together. Take those, the m and the 5, just multiply them together. That's a 5m. And if this was a plus, remember, each of these formulas has a negative in it. It always goes in the middle. If it's not in the middle of this one, it's got to go in the middle of this one. And that right there is our answer. Again, if you know the formulas, they are easy. If you don't know them, if you're not going to take the time to memorize these and how they work, you're going to be in big trouble because there will be problems you flat out cannot do. You can't work your way through it. Okay? Let's take a look at the next one. Perfect cube of y, perfect cube of z. So I write down the y and I write down the z. What sign goes in between here? It's a minus because that's a minus. Then I write down a perfect square here. I write down a perfect square here. I multiply the two of those together. So that's going to be yz. And if I've already used my negative over here, all the other ones here have to be positive. Done with the problem. That's it. Okay, are there any questions? Okay, would you do the next one and then check with your neighbor, please? Take out the greatest common factor if there is one. There are two terms. It's got to be on that list right here. It's got to be one of these things right here. All you have to do is figure out which it is. It's a difference. Is it a difference of squares or a difference of cubes? Difference of squares. Perfect square of 10c, perfect square of 1. So I write down the 10c and the 1 with a minus, same operation here. And then the other one, got to be all positive. So I write down the 10c plus 1 over here, and that right there is the answer. Okay, are there any questions? Okay, need everybody's attention then? Okay, here's a complete list of the rules that we're going to use. I'm only going to run through 5 more problems, and then I'll turn you loose on the assignment. These are all the rules. The thing that makes this difficult, is everybody listening? The problems you're going to have on today's assignment, for the most part, are either going to be a difference of squares, a difference of cubes, or a sum of cubes. Not going to be anything else. When we mix these all together on a quiz in section 5.6 on the test, the hard part is keeping all of these straight. So you don't really need to memorize this list and say, oh, here's step 1, here's step 2, here's step 3, and so forth. But you do need to be aware of these and definitely have those formulas memorized. So the checklist you run through is, as always, make sure you take out the greatest common factor first. And then we count the number of terms. If there are 2 terms, we know it's got to be one of these 3 things that we've been practicing today. If there are 3 terms, we know it's got to be a perfect trinomial square, an easy trinomial, or a hard trinomial. Okay? If there are 4 or more terms, we group it so that we can make a greatest common factor or make it fit one of these other patterns here. And the last rule is, okay, so you got to know the first and the last rule. Take out the greatest common factor and always factor completely. Okay? So let's run through a couple of problems. Again, most of these that you're going to see today fit in these categories of difference of squares, difference of cubes, sum of cubes. In fact, most of them, difference of cubes and sum of cubes. So let's take a look at this one. Does anybody notice anything weird about this? Okay, it's in the wrong order, but is there anything wrong with that as far as the difference of cubes go? Not really. If you wanted to change the order and factor out a negative, that would be okay. I'm not going to do that in this particular case because it starts off with a positive. I don't mind that. Perfect cube of 2 and a t. So I write down the 3 and the 2t in one factor. If this is a test question, I will be really, really disappointed if everybody doesn't at least get this first part right. You write that one down, you write this one down, the first one and the second one. What sign goes in here? A minus. Then all the other ones have to be pluses, because remember, there's only one negative in the formula. Starts with a perfect square of this one, ends with a perfect square of this one, so that's a 4t squared. At least get that far. Really disappointing if you can't get at least to there. I mean, and if this is worth 5 points, how many do you think you'd get for getting to here? Probably at least 3, because this is the toughest part. Okay? And it's just the 2 of these multiplied together, so that's going to be a 6t. Now, do we have to stare at this and say, hey, wait a minute. Mr. Laws said we've got to factor completely. This is a trinomial. Maybe I should try and factor that trinomial. This is prime. That's always going to be prime. That trinomial that's left over from a difference of cubes or a sum of cubes is always going to be prime. So we are done right there. Got confidence in our answer. Next one. 2 terms. Wait a minute. Not a perfect cube. So what do? Okay, we go back and we say, well, wait a minute. Always take out the greatest common factor. So if I take out a 2, I'm left with a y cubed and a 64. And now I recognize both of those as perfect cubes of y here and of 4 here. So I write down the 2. Don't forget that. I write down the y and the 4. I put a minus in there. Then I'm going to do a perfect square of the first one, a perfect square of the last one. Then I'm going to multiply them together, and there is my answer. It's practice. It's saying that over and over in your mind. Perfect cube minus a perfect cube of the first one, perfect cube of the second one, first one minus the second one, first one squared, last one squared, 2 of them multiplied together. It's a matter of understanding which sign goes where. Okay? All right, let's take a look at this next one because this is different. Most people like decimals better than they like fractions. Would you agree? Not in this one. Not in this one. My gosh, stop and think. Let's see. 1,000th is a perfect cube of what? Now, if you know that answer and you think about it for a second, it's not that bad. But for most people, it would be easier if we thought about it this way. This is 1,000th. perfect cube of x, perfect cube of 1/10. So whether you write it this way as a 1/10, oops, let me back up here. If you write it this way as a 1/10 or you write 0.1, I don't really care. But either way, it's going to be x and 1/10 because that's a plus, that one's a plus. Now, everybody watch please. What sign goes in the middle of this one? It's got to be a negative because remember, there's one negative in each one of the formulas. It's got to go in the middle. If it's not in the middle of the first one, it's got to go in the middle of the second one. So this is going to be x squared. This is going to be 1/100th because 1/10 squared is 100th. And then I multiply those together. I get x over 10. And remember, there's only one negative, so we've got a negative here and a positive there. And there's our answer. Okay, any questions? Sure? Okay, so let's take a look. Okay, can I enlarge this? Because we're going to need to take a good look at these two right here. Okay, all right. So I'm going to blow this up, and we're going to take a look at this one. No common factors other than one, but that's kind of silly on this one. Two terms. Difference of squares. No way, because it's not a difference. Difference of cubes. Again, no way, because it's not a difference. So we jump immediately to, it's got to be, if it's going to factor, a sum of cubes. Okay, 1 is a perfect cube. Is t to the 6th a perfect cube? Is t to the 6th a perfect cube?
Yes. Yes, t to the second.
It is. I could take something and cube it and get t to the 6th. What would I cube?
T to the second.
I'd cube t to the 2nd. So t to the 6th is a perfect cube of t squared. So it's going to be t squared and 1. What sign?
Plus.
Plus. Square this, t to the 4th. Square this, 1. Multiply them together, t squared, and I only need to decide what to put in front here. Got to be a minus. There's only one negative in each formula. It's got to be in the middle. If it wasn't in the middle of the first one, it's got to be in the middle of the second one. Are there any questions? Yeah.
Couldn't you factor the very first one? No,
Factor
not
this?
It's sum of squares.
Okay, Zach says, can't we factor this one right here? My gosh, it looks like we ought to be able to. It's t squared plus 1. But if I thought about that for just a second, there are no t's in the middle and there's a 1. So let's see. I'd have to have two numbers that multiply to be a t here and here, t squared here and here. Multiply to be 1 and combine to be 0. Nope, that's what we ran into before. That's why there is no formula for a, what would we call this if it did have a name?
Sum of squares.
Sum of squares. There is no formula for sum of squares. Okay, are there any questions? Done with that one. Let's come back here and take a look at this one. Okay, does anybody have this one done? Completely?
Yes. So I'm getting it. I know
Okay.
what to do. What you
Because this is a tough one. There are no common factors. It's a difference. Difference of squares or difference of cubes? You want to do cubes? Okay. So this is a perfect cube of p squared. This is a perfect cube of q squared, right? So that means this factors 2. Okay. Now we're doing perfect cubes, right?
Yes.
So if this is a cubed minus b cubed, this is a minus b. Then it's going to be, well, let's see, this would be a squared plus ab plus b squared, right? So this is going to be p squared minus q squared. P to the 4th, q to the 4th, and the middle one would be plus p squared q squared. Is that right? What's that? Oh, plus. Thanks. Thank you. Good there? Okay. Is it factored completely?
No.
It is not. It's not factored completely. I can break this one down to p minus q and p plus q. And then I've got p to the 4th plus p squared q squared plus q. Call that a Q. All right, now call it a Q. Q to the fourth. Good? Okay. Who thinks we're done?
No.
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 Pull a square out of the piece for.
No.
We can pull a square out of here?
Well,
Okay,
no.
if you look at this as it is right here, okay, and thought about, I could try a p squared here, and I could try a q squared there, to somehow make that middle one, you're not going to come up with numbers that multiply to be 1 and add up to be 1, okay? So you can't factor this, okay? But let's try something else. Now, you wanted to start doing this by thinking of this as a difference of cubes. It was that cubed minus that cubed, right? But could we think of it this way? Could we think of it as, so is everybody okay if I erase this? You've got this written down. You can just watch the rest of this.
Was that the right answer?
We'll see. We want to factor completely. If we thought of it this way, let's think of it as a difference of squares. This would be p cubed squared. This would be q cubed squared. So then this would be p cubed minus q cubed and p cubed plus q cubed. Now, what is the difference now at this level of factoring as to what we had before? Yeah.
Well, instead of, well, now you can break the p cubed and q cubed, but you can't.
You can factor them both. Okay, remember before we had this difference of squares and we had something that we couldn't factor here. Now we've got a difference of cubes and a sum of cubes, both of which can be factored. So this one factors to p minus q, then it's going to be p squared plus pq plus q squared. This one can be factored to p plus q, because that's a plus. I'm going to have a negative in the middle of this one. P squared minus pq plus q squared. And that's broken down completely. Now, correct me if I'm wrong, but on that last one, the answer that you have this factor and this factor. And then you've got this other factor of, let me see if I can remember what it was. It was p to the fourth and ended with q to the fourth. And the middle one was plus a p squared, q squared, right? Isn't that what it was? Well, if you take this and break it into two pieces, you could use some really advanced factoring techniques, okay, which we're not going to learn, and I don't even know. I could probably struggle my way through and find it, but I wouldn't want to do that. So if you have a choice between writing things as a difference of cubes or a difference of squares, take the difference of squares like we did on this one, because it breaks it into two pieces, both of which can be factored. Okay? Now, that seems to me like a fabulous test question. Doesn't that seem like it to you?
Yeah. Well, I don't want to do it.
I wouldn't put one like that on a test unless it were like a bonus question.
No.
Okay? But that's an interesting idea right here, isn't it? If you have a choice, remember, so this is one logical way you could think your way through it. Okay? This one, if these are both perfect cubes, might be able to be factored. We know that these two factors right here are prime. Okay? You can't factor them using any technique that we're aware of. Okay? All right. Does that make sense? Okay. Any questions? Sure? Okay. Go ahead and get started on the homework.